assignment compatibilities. Now, when we say compatible, it means that they are compatible, so we can move one value into the other one. Assignment compatible. Assignment here, we means the equal sign we use for equations. If you recall that the equal sign in computers doesn't mean that you compare. It means move whatever you have on the right hand side into the left hand side. So the left hand side of equal sign should be variable. On the right hand side, it can be constant, it can be expression, and it can be another variable. So the assignment statement is the equal sign. So here it says you cannot store a value of one type in a variable of another type unless the value is somehow converted to match the type of the variable. So it is not free that you can move any data type into any other data type. But if you want to do that, you have to convert. So as an example, suppose you want to move double into integer. Is it allowed? If it is not allowed, then you need to convert it. Can you move, for example, integer into byte? If you cannot, then you need to convert it. So how to tell if it is allowed or not allowed? It's called compatibility. And here we have a list of the data types we have covered so far on numbers. So I'm talking about numbers here. When dealing with numbers, you can assign a value of any type on the following list to a variable of any type that appears further down on the list. Further, it means far away. So see the arrow? It's going from left to right. That means you can move any data type in the list to any data type to its right. So you can move, for example, short into integer. You can move short into float. You can move byte into double. As long as the smaller value is on the right hand side of the equal sign, then it is compatible. Because how to move a value? Suppose you want to move x into y. You want to move x, copy x into y. So you write y equal x. So on the right hand side will be x. So if you want to move one value into another one, remember to move a smaller value into larger value. So byte is smaller than long. So you can move byte into long. Long is smaller than a float. Here it is assumed that float and double are larger than long. So this is the rule. Here are some examples. Here you have an integer variable called value and has the value 3. And you have a double variable called salary. It has 1,200. Now here you are moving value into salary. So value is integer and salary is double. So you are moving integer into double. So is it allowed? Let us see where is integer. Integer is here. And let us see where is double. Double is here. So you are moving integer into double. So it is valid and it is allowed. However, if you switch, if you want to move salary into value. So salary is defined as double and value is defined as integer. So you are moving double into integer and it is not allowed because double is on the right hand side larger than integer. So this is invalid. But if you really want to do this, because see salary, the value for salary is 1,200. As an integer, this number, see it's an integer, there is point here, 0.0. So as an integer, if you want to move this value, the constant 1200, it can fit into integer because the range for integer is very large. So suppose you want to tell Java, yes, I know you cannot move salary into value, but since the number is small and it can fit into integer, please convert it. So here we will ask for conversion. And how to do the conversion? It's called typecasting. So typecasting is simply converting. So if the variable if the value you want to move into another variable, or another if you want to move a value of a variable into another variable, if they are compatible, it is fine. If you want to make conversion, then you have to do typecasting. So how to do typecasting? In many situations, you cannot store a value of one type in a variable of another type. For example, you cannot move double into integer. In this case, you may use a typecast that converts the value to an equivalent value of the target type. How to do it? This is the syntax. In front of the variable you want to convert, you put between round parentheses the type of the target variable. So if you want to convert a variable that is double into integer, so you write between brackets int in front of the variable. Here are some examples. 7.9 is double, but if you write in front of it between round brackets int, here you are telling Java to convert it, and you know to convert a real number into integer, you simply ignore the fractional part, regardless of what is the value for the fractional part. So here 0.9 probably is big. This is not rounding. This is converting. So it will truncate. It means remove any fractional part of the variable. So the answer will be 7. And if you want to convert an integer into double, the compiler will simply point. So this is no problem here. If you want to convert integer and double, you will not lose any of the data. But if you want to convert double into integer, you are losing some of the data because you are converting. This is why when you convert double into integer, make sure that the converted value can fit into the integer. Otherwise, the computer will truncate, it will cut, and it will put an invalid value into the variable. Now here we have an expression that involves divides, but notice the conversion is only on the integer 15. So 15 will be converted into double, and it will be 15.0, and 2 is not converted. So double over integer, if you remember that the answer is double, and the answer will be 7.5. And last here, we are converting 7.9 into integer, the answer is 7. 6.7 converted into integer is 6. Adding integer with integer, the answer is integer.